Hi everyone, welcome to TOPML 2022. I'm excited to start this workshop for the second time. My name is Yehuda Dar, and I would like to thank my co-organizers, Misha Belkin, Gita Kutiniok, Ryan Tibshivani, and Rich Bereniuk. It was a pleasure to organize this workshop with them. The motivation to the topic of our workshop is that deep neural networks are over-parameterized models in the sense that they are highly complex and have many parameters with respect to the amount of training data. Moreover, these over-parameterized models are often trained to perfectly feed their training data, meaning that if you give an input from the training dataset to such a trained model, the output will be exactly the same like in the training dataset. In a more foundational example, if we have real-valued inputs and a real-valued output, then we learn the brown curve, like here, and this curve goes exactly through the training data points in the magenta markers. But of course, the actual goal is that this learned function will operate well on test data beyond the training dataset. This means to generalize. The conventional machine learning guideline says that overfitting training data is bad for generalization. To be precise, this is mainly true when data is noisy. And therefore, conventional machine learning wisdom suggests to learn a function from a low complexity solution space, like this blue dotted curve. And therefore, it cannot perfectly fit the training data, and it generalizes nicely if you do it properly. However, recent deep learning practice amazingly shows us that perfect fitting or interpolation of training data and state-of-the-art generalization performance can coexist. And this establishes one of the major scientific challenges in modern machine learning theory, which is to understand generalization in over-parameterized learning also beyond deep neural networks. One of the prominent elements in over-parameterized learning is the double descent phenomenon that extends the classical bias variance trade-off from the under-parameterized regime to the over-parameterized regime where all solutions perfectly feed the training data. At first, when the learned model complexity is sufficiently high to perfectly feed the training data, the test error arrives at its peak. But then, remarkably, when we further increase the learned model complexity, the test error can decrease, and in some cases, it can even achieve the global minimum of test error, even with respect to the under-parameterized regime. So this is a remarkable phenomenon that contradicts the conventional machine learning wisdom. The research area of the theory of over-parameterized machine learning tries to explain such kind of phenomena. And these studies form an emerging subfield of machine learning theory that explicitly consider exact or near interpolation of training data. The recent progress and huge interest in this topic can be observed in these three overview papers from the recent year. Each of these papers take a different perspective to explain the foundations and overview this topic. About our workshop. So our workshop is focused on the understanding of over-parameterized machine learning in the sense that we are interested in studies that explicitly consider exact or near interpolation of training data. We are mainly interested in theory, but also in empirical findings that can promote new theory and new aspects of foundational understanding. We also welcome diverse research disciplines and perspectives and encourage discussion among them. And to achieve all of this, we have, first of all, a great group of speakers. We have 8 invited speakers this year. Today, we will have 4 invited talks by Lenka Zdeborova, Andrea Montanari, Jeffrey Pennington, and Vidya Muthukumar. Tomorrow, we will have 4 more invited talks by Francis Bach, Daniel Su, Caroline Uller, and Edgar Dobrivan. We will also have 6 contributed talks and 20 lightning talks that were selected in a review process. So this is a great opportunity to thank all the reviewers and whoever submitted their work. We have many registered attendees, so you're welcome to ask your questions through the Zoom Q&A feature or through the Zoom chat. And at the end of each of the talks, you will be able to ask your question by yourself with your microphone. So we are set to start the TOPML workshop 2022. Enjoy the workshop.